Welcome, bienvenidos to this first of three webinars hosted by the Barcelona Institute for Global Health, or IS Global, along with the después platform, where we'll examine the linkages between global environmental change, the COVID pandemic, and progress towards the Sustainable Development Goals. I'm Catherine Tunna, an environmental epidemiologist and associate research professor at IS Global. We will kick off with a few words from Oriana Ramirez. She is a policy analysis coordinator at IS Global and an expert in health and development. And Oriana will tell us about the Dia Después platform. We will then hear from Josep Maria Anto, who will provide an overview of why COVID-19 should be seen as a planetary health issue. Josep Maria is a professor of epidemiology at IS Global and the University of Pompeu Fabra, and was for many years the scientific director of IS Global and the director of its predecessor, CREAL. Oriana, over to you.
Thanks a lot, Catherine, and welcome everybody. So I'm here to introduce you to El Día Después in Spanish, the day after. This is an adaptation to the times of crisis of a multi-stakeholder initiative created to promote and accelerate the fulfillment of the SDGs, the Sustainable Development Goals. Behind it, we are 4 institutions that we have funded this initiative. REDS, this is the Spanish chapter of SDSN, Sustainable Development Solutions Network. The Innovation and Technology for Development Center at Universidad Politécnica de Madrid. The Barcelona Institute for Global Health that is co-hosting these webinars. IS Global, you may know it, and Iberdrola, which is an electric company, international company, plus around 50 or more new institutions that are signing in as collaborators. So last year we had an event around the acceleration of the 2030 agenda, and this year we were thinking of another event around how to fund the implementation of SDGs when this public health crisis exploded. So with all these efforts in place, we reconducted these efforts into an online platform capable of learning from the crisis and integrating the conversations that were already happening, taking place between different stakeholders. And we do so out of the deep conviction that the roadmap established in the 2030 agenda is more relevant than ever. And it is time to celebrate the inescapable transformations that the SDGs pose. So El Día Después is an open, innovative tool, please feel welcome to it, which enables massive collaboration between people and organizations, generating proposals that arise from this collective intelligence. There are 4 thematic communities so far. The first one is the environment and health, which is the community that is proposing these webinars. Another one is about sustainable cities, which, by the way, are having an online big event tomorrow. Please check in our website for that. A third one would be inequalities and new economic models, and a 4th one, international cooperation. But we will probably expand the areas of work in the near future. These are open workspaces with a practical and purposeful vocation, where diverse people from different organizations are called to collaborate, whether scientific community, companies, public administration, third sector, citizens, etc. There are 4 tools, 4 specific collaborative spaces currently available in the El Día Después website that you have in the slides. These are Agora. This is a place inspired in COP25, a space for collaboration between the different thematic communities aimed at connecting both public, private, and social decision makers. A space to co-create called Collab, imported from the MIT at Harvard, where we can reach consensus on a specific questions posed by a group or build proposals to pilot actions. So please think about this as these 3 webinars are going to happen. Conversations with experts like this one, webinars or seminars that are more specific in nature, aim at a more specialized audience, and others like a knowledge space, press and communication room, and a data laboratory. So let me end by wishing this series of conversation a fruitful exchange of ideas and action proposals, and feel free to canalize those by any of these tools that we just proposed as part of the EED El Día Después platform. Thank you very much.
So I think it's now my turn. So I'm Josep Maria Antó. Hello to everyone from Cornellà, near to Barcelona, where I've been, as many of you, more than 40 days confined. And thank you very much to the organizers, especially to Manolis, Catherine, Oriana, for your capacity to organize this incredible initiative in such difficult times. I hope you all are doing well, and especially thanks to those of you that may be at the front line taking care for others. I will, in my presentation, and I will share immediately with you, sorry. I will, in my presentation, propose you a planetary health framework to explore the role of environment as part of the proximal and distal causes of the COVID pandemic. And in doing this, I will deal with two related issues. One is to understand how the proximal, which are the proximal causes of the COVID-19, and especially to approach them as an interplay between infection and environment, including factors like climate, air pollution, and many others, before, during, and after the pandemic. And the second one is about the distal causes and how to approach the distal causes, looking to how global environmental changes like biodiversity, climate change, or global pollution are interplaying together to determine the occurrence and modulating the impact of the COVID. The science landscape of COVID-19, it's, as you all are aware, dominated by ignorance and by uncertainty. And I took this photography of Filippo Minelli, a young Italian artist, as a metaphor of our ignorance. Silence Shapes, the collection to which this photography belongs, is a series of photographs from Minelli that document interventions in the space that the artist carry out in relation to political or region or religious protest. And importantly for Minelli, silence becomes a place, a space, a physical and a mental landscape to contemplate and explore. And using this metaphor, I will explore the role of environment as part of the proximal causes of the COVID-19. And I suggest that we adopt this conceptual diagram that is modified after the one published in the 5th report of the IPCC in 2014. And in particular, I suggest that we look at the risk of COVID-19 as an interplay of hazard, exposure, vulnerability, and resilience. Well, first of all, the risk obviously refers to the COVID-19, and we need to understand COVID-19 from a double perspective. One is individual, so it means the risk and the impact of one individual becoming infected and developing the disease. And the second one is the population. So it's the risk of the risk and the impact of the population having an epidemic of the disease. The hazard, obviously, is the SARS coronavirus 2. And importantly for epidemiological models, this hazard is a necessary cause of the disease, something that usually is not the case in many environmental epidemiological models. We still know little about the virus, but some of the characteristics of the virus, for instance, its relationship with the common cold coronaviruses and the cross immunity, or the seasonal behavior of the coronavirus and the opportunity of seasonal forcing are, despite ignored, potentially very important. Regarding exposure, to be relevant for the COVID-19 risk, the exposure to the virus needs to interplay with other factors to cause either the disease or the epidemic. And we know that most of the time, the exposure is mediated by person-to-person contact, contagion. But we should not exclude the possibility of transmission via the presence of the virus in the environment. So this would be the environmental dissemination. And despite there is some understanding of this from the last SARS epidemic in 2003, there is almost no knowledge for the current coronavirus too. Very important for both types of transmission, the person-to-person and the environmental one, there are likely to be many relevant environmental co-exposures playing a role in different ways. And this, as you can imagine, could include climate-related factors like temperature, humidity, or winds, both surface and high altitude winds, air pollution, land use, urban configuration, sanitation, or even foods, if these foods are contaminated and then transmitted via consumption. And very important, and most likely also, socioeconomic factors like education, socioeconomic status, employment or unemployment, and all them both at the individual and the population based. But even when all the relevant exposure factors are present, we are likely to see substantial variability in the distribution of the risk, both individual and population. And this will be in part explained by vulnerability and susceptibility. Again, here we have factors at both the individual and the population level, including age, sex, comorbidity, immunity, genetics, nutrition, socioeconomic status, other factors, and very importantly, health services and social policies. And finally, but not less important, is resilience. And I think we should pay importance, we should pay attention to resilience in all our scientific models, both as individual as a collective dimension. Here in resilience, I include both mitigation, including interventions as tracing and isolation, social distancing, environmental interventions like we have seen these days, disinfection of public spaces, or also pharmacological and other non-pharmacological interventions. If mitigation is not enough for the extinction of the virus, which is most likely to be the case, then adaptation in the short and in the long term are going to be very important. Let me now move to the distal factors. And to explore the distal factors, I suggest you to use this conceptual diagram that was published in the well-known paper by our admired Tony McMichael in his New England Journal paper in 2013. Well, the figure, as you can see, is a schematic representation of three large domains: demographic and social changes, economic activity, and environmental impacts. And all these three components show two-way interactions between them, but very important, the confluence of all them on the central fact that all the three domains influence in the conditions for and the levels of the population health. Tony's work was pioneer to the concept of planetary health and to the idea that not only environment is important for health, but also human health is very important for environment. And this simple concept that the human health and the health of the planet should go together is, to me, of paramount importance in the context of the Anthropocene and the existential climate crisis that we are facing. Based on this Tony's McMichael approach to the global changes in health, Christina O'Callaghan and I took advantage of these confinement days to work together in exploring how distal factors could have been involved in the causation of the COVID-19. Well, obviously, it's still too early, and most of the evidence about the precise origin of the COVID-19, it's still circumstantial. However, we found abundant evidence, I would say basically background evidence, to elaborate on these factors. Well, you can see demographic changes. Demographic changes and social factors are clearly involved in COVID-19. One is the massive national and international mobility, which is part of our economic system, but also aging and urbanization are clearly involved. Well, social changes can be of very diverse nature, but certainly the lack of a robust global governance model of public health, including the governance of the European Union, it's important. And as we know, unfortunately, the globalization of the economy has not been followed by a strengthening of the global governance mechanisms, and especially those of public health. Well, regarding economic activity, current changes like large scale and systemic environmental impacts due to extinction of species, decreased biodiversity, deforestation, and natural habitats have been linked to, in different contexts, the transmission of viruses to wild animals and to the emerging zoonosis. And you have in the references some of the papers that support these statements. Well, the Spanish artist Isaac Cordal sees the city as his playground. He has specialized in miniature street art, producing tiny figures as a social commentary on the spaces that we all inhabit. For several years, he has been working in the 7 Eclipses project, referring to the state when a building covers the sun. So from here, the title of 7 Eclipses. In his own words, it is a critical reflection of the idea of the progress. My work, he says, is a filter to try to understand and change the world that we have created. And this photography is for a very recent work, indeed, December 2019 in New York. Well, to finish, I would like to conclude with few general ideas. The first one is that COVID-19, it's not a random nor a usual crisis as we all are aware of. It is indeed an unprecedented one. COVID-19 reveals a context of global negligence in public health and beyond. Research, translation, implementation, and education are crucial, but they are crucial to pave the way through large-scale political changes. Otherwise, the new knowledge and its translation will lack impact. In this context, the planetary health approach provides, to my view, a unique opportunity to understand how proximal and distal factors are interconnected with the COVID-19. And finally, COVID-19, I propose, can be seen as a systemic crisis which origin and far-reach consequences should be understood in the context of the climate crisis and the Anthropocene. It is from this perspective that Christina and I have suggested that the COVID-19 can be seen as a disease of the Anthropocene, or it could even be seen as a tipping point of the Anthropocene? Well, let me finish with imagining all you having shown some interest and thanking all you so much.
Many thanks, Oriana and Josep Maria, for setting the stage so nicely. We will now have short presentations from our three panelists on more specific topics before moving into a discussion. We are delighted to be joined by our panelists, who will no doubt provide many insights from their respective fields on how we got here, the point where we are facing a global pandemic with enormously far-reaching implications for health, society in general, and global sustainable development. First, we will hear from David Savitz from Brown University in the US, where he is the Associate Dean for Research, Professor of Epidemiology, Obstetrics, and Gynecology, as well as Pediatrics. David will talk to us about the potential role for global environmental pollution to increase susceptibility to infections. Fernando Valladares will then cover the role of land use change and biodiversity loss in the emergence of the SARS-CoV-2 virus. Fernando is an ecologist and research professor at the Spanish Scientific Council in Madrid. And our third speaker is Julia Vergara, who will then go into a bit more detail on the emergence of zoonotic pathogens. Julia is a doctor of veterinary medicine and researcher at the Center for Research in Animal Health here in Barcelona. David, the floor is yours.
Thank you. Okay, let's now if my skills have improved over the past month, and we'll see if I've gotten where I need to be. So slideshow from the beginning. Very good. Let me thank Catherine and the organizers of this discussion, which I think is obviously timely. I admit that the kinds of issues I'm raising are for longer term discussion and will help us understand what happens more towards the future. I think about it as a sort of an analogy to when the time to worry about global warming is always, it's not only when we face a disastrous heat wave or a disastrous weather event or in air pollution. The time to be concerned is not in the face of a major inversion. Of course, that's an acute crisis, but these are predictable if they're not random, as Josep Maria indicated, but in fact, they are inevitable with the passage of time. So I'm going to explore and sort of reflect a bit on the more academic side of this, but hopefully with some lessons that are relevant to policy. And the academic cultures of environmental epidemiology and infectious disease epidemiology have largely functioned quite separately. And one of, I think, the major contributions of IS Global is really at the highest level bringing that kind of thinking together. And I think there's tremendous potential to address issues of this nature. Both are advanced, productive, and very distinctive, with environmental epidemiology focused on the traditional issues of exposure assessment, looking at the impact of pollutants on disease and how to reduce that impact. Infectious disease is largely focused on the vulnerability issues, what causes infection to spread, and of course interventions to reduce it. But really, at least in the US and I think in much of the world, these are in separate arenas in universities and in public health departments. I think even in public perception, I don't think that people would be naturally drawing necessarily connections between air pollution or water pollution and the current crisis. There are commonalities, as I mentioned. Both fields are concerned with prevention, and really ultimately infectious disease is an environmental disease. It is transmitted through the environment. And so there is a shared concern about where people live and work, and some of the very high level factors that Tony McMichael's paper discussed are certainly applicable to both. They're both focused on exogenous determinants of disease by and large, of whether that's chemical or physical pollutants and microorganisms. Uncertainty about the magnitude of health impact and how to best reduce it. And I think these are probably among the most prominent public health concerns that you will read about in the newspaper on an ongoing daily basis now, of course, but they are of great public concern and great societal concern, even beyond the health arena. These are truly societal issues. The field that we need to be developing and really cultivating is environmental infectious disease epidemiology. And it certainly is beginning when we talk about the built environment, social environment, and certainly the microbial environment is part of the world in which we live. And similarly, from the infectious disease side, we're certainly familiar with some of the ways in which the environment has an impact on the spread of infectious diseases, most classically through, for example, vector-borne diseases, but also crowding, water sanitation. It's very parallel to environmental toxicants. And what I'm going to examine is just some illustrations of where these areas have converged, and talk at the end very briefly about ways that we could do a better job of nurturing the intersection. So there are, I was involved some years ago in some work related to agricultural activities, which of course are a concern for environmental health issues. And it's really getting at the issue of microorganisms as pollutants. And we've had a long-standing focus, of course, on the health impact of pesticides or fertilizers, the contamination, and the use of intensive livestock operations in the United States, and again in other parts of the world, raise new concerns with the potential for fecal contamination of drinking water. And basically the concern being that through the leaching or leakage of these waste ponds, through flooding and distribution into reaching human populations, there is a spread of infectious diseases that inevitably, predictably will result. And in a sense, of course, the coronavirus spread is a product of a sort of agricultural practices polluting the human environment through complex biologic pathways, but nonetheless is an interconnection between the worlds of agriculture and infectious diseases. And I think one of the ways to sort of conceptualize this is this notion of the exposome, where it's more neutral in the array of factors that bear upon disease risk, including chemical and physical agents, but also microorganisms, social factors, economic considerations, and so on. And I think that all-encompassing view is exactly what we need to be pursuing. In some cases, there's an interesting trade-off of the management of chemical and microbial pollutants. And one of the areas this has come up in is with regard to water chlorination. Clearly, sanitation of drinking water has probably been the most profound public health advance in human history. However, there are still microbial threats to drinking water. It is something that requires constant monitoring and treatment to be managed. And water chlorination to control infection risk in this way generates chemical byproducts at low levels, but these chemicals include known toxic agents, mutagens, and carcinogens. And there is an ongoing and evolving discussion of the optimal balance of the engineering controls, and there's a trade-off among the tolerable levels of the chemical contaminants, the baseline risk of infection, and the costs that we're willing to bear. And there are other analogies here with just using the illustration of pesticides and malaria, where decisions need to be made that require a joint understanding of environmental pollutants and infectious diseases. Now, climate change, of course, is very interesting and is extremely of compelling importance. And there are many infectious diseases, as we know, that are spatially limited or circumscribed, that is based on climate and weather, and certainly including extreme weather events. Floods obviously change the infectious disease risk rather markedly. And perhaps there's no more obvious or direct impact of global warming than expanding the range of tropical diseases. And this is well understood and quite predictable. But it's, again, an illustration of climate change and the infectious disease intersection. And it gives us an opportunity to anticipate, to avoid if possible, but also, I think, realistically, given where we are on that process, to be prepared and be ready to mitigate problems that are already in progress. Now, an area that is, again, probably maybe the most novel, but could be in the long run the most important, is the role of environmental pollutants and their impact on immune resistance to infection. It's well known, of course, that with severe immune deficiency, the risk of acquiring infection is increased, and also the severity of disease that follows the infection is markedly enhanced. So we have the, if you will, the high dose counterpart that shows this is an important determinant of disease risk and disease spread. And there's growing evidence that chemical pollutants can negatively affect the immune response, the effectiveness of our ability to respond and protect ourselves from these agents. It's not likely to be an all or none response. It's not going to be as dramatic, let's say, as someone with a genetic immune deficiency, but it is a subtle, widespread effect that affects the population level risk. And one of the areas this has been explored recently that I've been involved with is in regard to perfluoroalkyl substances, PFAS so-called, where there is growing evidence that these chemicals are capable of impairing immune response and therefore may in fact increase susceptibility to infection. The studies that have demonstrated this are, I think, very, very creative and very interesting, of looking at vaccine response, where when we administer vaccines, of course, we're looking for the antibody titer to be increased. And it's an unusual opportunity in large human studies to see the variation in that response in relation to pollutant exposures. And there's fairly consistent evidence of a modest impact, mainly in children more than adults, where those with higher levels of PFAS exposure tend to have a somewhat suppressed response to the vaccine. Now, this should probabilistically, in principle, increase the risk of infection, but that's much more difficult to demonstrate. And so that the evidence linking PFAS directly to infectious diseases is much weaker than the evidence linking PFAS to a depressed or suppressed vaccine response. Now, again, they have to put it in quotes, the cliche, of course, of all researchers, that more research is needed. But I think this is an area where the potential impact is quite high and the level of knowledge is unusually low. It's exactly where we need to be focusing our research efforts in the long run. And we really need improved methods to study this connection between environment, immune function, and disease. And the elements include, of course, the ability to understand the exact implications of a small variation in vaccine response on disease risk, but also the methods of detecting a subtle difference in the rate of infectious diseases. We're not talking about unique diseases being caused. We're talking about a small increase in very common diseases that require special kind of research efforts. Secondly, this needs to be incorporated into population models, that we aren't going to be able to gather all of the detailed empirical data we would like, but we're going to have to model what is the impact of a 5% reduction in immune response. How does that bear on the overall population risk? And I think, of course, it's very likely to. Every lever that moves immunity up or down, even modestly, is going to have ramifications throughout the population. And finally, considering, at least as we're looking at the ways of mitigating infectious diseases, and again, I think that the slide that Josep Maria presented from Tony McMichael's paper, all of those factors that are driving global health are levers of potential improvement in global health, and the role of environmental pollution, and with all of its well-established benefits, it's well worth examining much more closely how that can help us in the avoiding and mitigating the kinds of crises we're facing now. So that is the concludes my my comments, and I will look forward to the discussion. Thank you.
Hello. So thanks a lot for the invitation for this fascinating webinar, very timing. Thanks to all of you that are following this webinar, this session. And let's begin. I will share my screen with all of you. Let's see. I think it's here. Okay. Okay. So basically, my idea is to describe briefly the scenario, the ecological, environmental scenario regarding land use change and biodiversity that made the COVID-19 kind of a global disaster or challenge. We are seeing these days a lot of these images that are very encouraging, showing animals, showing the nature, coming to see us and giving symptoms of eventual recovery. We see a lot of animals, but actually, is this showing a recovery? What is full recovery? I think the full recovery is not only some species here and there, but it's the recovery of the function. As an ecologist, I would like to emphasize about the many functions that sometimes we forget, we don't know, we cannot quantify, but nature, biodiversity in particular, but nature in general, gives and provides to all of us. We've seen this girl, Greta Thunberg, saying to the United Nations things like, we are facing the sixth mass extinction. The rate of extinction is 10,000 times faster than normal, and every day 200 species disappear. I think she's pretty right. We can look for reports, we can go for graphs and statistics, but basically she was very right. For instance, another number, just to put us in kind of in the framework of our alteration of the planet, we human beings and our domestic animals represent roughly 98% of the fauna of the world. 40% of the surface of the earth is completely artificialized, urban, suburban, agricultural, etc. 37% is made of natural habitats, but they are still heavily modified. And only 23%, less than a quarter, can be classified as wild. And many are in remote places and in deserts and Arctic regions. This platform, the Ecosystem Service Platform, the IPBES, is producing reports, and last year produced a very dramatic, so to speak, report summarizing the scientific evidence on our impacts in the terrestrial and freshwater and marine ecosystems. In this graph, you can see almost in the center the different drivers, and you can see in bluish and in purple the land-sea use change, which represents at least 20%, in most cases more than 30% of the actual changes and impacts. We can have in this presentation many numbers, all go in the same way, like all natural ecosystems decline, for instance, by 47%. There are many numbers. Obviously, biodiversity is not affected equally. Some groups of species are more affected than others, And for some species, we actually don't know, and we have to guess. Some species will probably disappear before we even put a name or give them a name. How did we get here? Well, by a collection of, let's call, environmental errors. We do not pay much attention to our environmental impact, and sometimes we alter the ecosystems, but paradoxically, sometimes in trying to fix or to do something regarding these errors, we made the errors even worse. There might be many examples, but for instance, biological invasions represent a good example of error after error. So not learning from what happened in the past and committing the same error and then trying to fix it. And for instance, the introduction of rabbits in Australia was followed by the introduction of foxes to control rabbits, which didn't work, and then viruses that didn't work either, and then return the viruses to Europe to make things bad for the native rabbits in Europe. Another reason that got us here is not listening to science. It's not that science didn't know. Science probably didn't know everything, but knew enough to raise some warnings. And for instance, this paper almost 4 years ago by Allen et al. With a map of the global risk of zoonotic infections is actually, as you can see in yellow in the upper right part, the Southeast Asia and the area of Wuhan as one of the hot spots for zoonotic infections. And I could probably present, and we all can dig in the literature and see many things that several years ago were showing the risk, showing the potential places to get started, showing the factors. I'm going to illustrate and to develop a little bit these factors that made the combination that produced the current COVID-19. It is a combination of new and old human activities. 4 of the main activities and factors that were involved in these pandemics were the wet markets, the illegal poaching and species trade, deforestation, and globalization. There are many others, but from the ecological point of view, those are important. And I want to emphasize on the functional aspects of biology and the functional dimension of biodiversity. Biology has been typically neglected in many modeling approaches. And typically in climatic models for more than 3 decades, biology was not present. And without biology, now we know that we cannot make good predictions. Climate change affects, for instance, by the biological system, the ecosystems, but ecosystems, biology affects the climate. And unless we introduce the climate and the biology together in the model, we will not be able to make predictions. And this is a lesson in general that we should look at it. And I'm going to illustrate, to develop a couple of minutes in showing how little we knew almost 20 years ago when an important heat wave hit mostly Europe, Central Europe. Most European countries were affected by this heat wave in July 2003. And it was actually the main productivity crisis of the planet in that century. You can see in the upper graph the estimated net primary productivity, and you can see that 2003 was the lowest in the 20th century. And it was not only that productivity crisis was associated with dramatic impacts in the human populations. The numbers, the official numbers and the estimated numbers are very different, but for instance in France, it is estimated that 30,000 people die, in Italy 20,000, in Spain 13,000, in Portugal more than 1,000. The exact numbers we probably will never know. That heat wave got us by surprise, and it took more than 10 years to understand exactly what happened in 2003. And this is the explanation. Basically, it was a warm winter that advanced the production of leaves, and it was followed by a very dry and warm spring. And by the time the heat wave reached Europe in July, it was not enough water for the forest to transpire. And without transpiration, the temperature goes really to an extreme record value. In that case, as in other cases that we are seeing, forests in particular, but ecosystems in general, did not do their function. And coming to the pandemics, I would like to illustrate something similar. Hopefully it doesn't take another 10 years. We don't have 10 more years to learn, to make the models, to simulate things. We should be faster and we should learn from the previous errors. With the pandemics, the current pandemics, the COVID-19 and biodiversity, I think it is very important to remember the job of biodiversity and to refresh what we know about biodiversity in protecting us from pandemics. In this little cartoon, I show the three main mechanisms, summarizing the results from the literature, on how biodiversity protects us, human beings, from zoonotic infections. The first, the most general one, is the demographic control of the species acting as a host of the virus. So an ecosystem rich in species, rich in interactions, an ecosystem that is functioning very well. It prevents from a given species, the species that can be the host, to be out of control and to get a demographic sudden and uncontrollable increase. The second mechanism is called dilution, and it refers to the fact that many similar species, mammals, for instance, in this case, could act as host species. Not all the species are equally good for the virus or cannot have the same viral concentration. The virus cannot develop as well in all the species. So some species actually block the transmission, and the overall density and amount of virus in the ecosystems is decreased, is diluted. This is why the name of the mechanisms. And the third mechanism, the buffering, it's the similar mechanisms as dilution, but within one species, and it takes advantage of the genetic diversity. So we should keep genetic diversity within species variety within a functional group, and then ecosystems that are rich in species. The importance of biodiversity has been shown in many scientific papers, in many studies, for the last 15 or 20 years. The West Nile virus transmission cycle, for instance, is a well-known good example, with reservoirs being birds and mosquitoes acting as vectors, and sometimes the mosquitoes brings the virus to the human population. A paper published by Osfeld more than 10 years ago made a clear graph and a sound statistics for 3 different years on how the incidence in human is decreased by the diversity of birds. So the more various numbers of species, the more diverse ecosystems in terms of having different bird species is associated or was associated in 3 different years with lower influence of this virus in the human population. Another factor that is very important, and we know there are pieces of evidence, is the preservation of the ecosystems. And for instance, for the case of forests, the size of the forest patch is crucial. And again, another paper, in this case, almost 20 years, more than 15 years ago, Alan and co-workers show a significant relationship between the forest fragment size and the density of infected ticks in this particular Lyme disease in the east coast of North America. Another example on how a well-preserved ecosystem can actually protect us from infections. There are many papers. I'm not going to show all of them. Some goes back 20 years in time, others 10 years. Others have been published in April this year by Johnson and co-workers, showing the different aspects of how biodiversity actually acts as a buffer. So instead of going into more details, I think I will make these 3 main options, a summary of 3 potential options, and hopefully we go for the first, for the best one, which is not the first, as you can see. But obviously, as a scientist, I want to illustrate the 3 potential options. The 3 options will be, first, to deny one or more pieces of this complex puzzle so as to simplify it and to restore the satisfying dynamics of good versus evil. We should choose our side and then assume things do not work because of the other side, whatever happens. The second option is to accept that in the present and in the near future, we have several possible choices, and none of them will avoid all major damage and suffering. We all will share responsibility for that. And finally, we are also maybe choosing not to choose. The choosing not to choose option will not prevent us from painful consequences anyway. And I'm going to leave it like that. And thanks again for this discussion and this brainstorming so much needed in these times. Oh no,
Sorry, Julia, we can't hear you now. Can you start from the beginning again? Can you maybe use your headphones? I don't know why. It is much better. Thank you.
Okay, so yeah, I just was saying that thank you very much to invite me to this interesting webinar, because I am not ecologist, I am not epidemiologist, so I am learning a lot. As Catherine already presented myself, I am veterinarian, and I am working on the, of course, on the animal side, let's say, of different disease, mainly zoonotic disease. That's why I am here today. So we will talk a little bit about some lessons we have learned from different viruses and how the relation between animals and humans got us where we are nowadays, no? So yeah, I wanted to talk a little bit about how disease in animals and humans can be interconnected, and how disease, for example, from a given animal species can be transmitted to another animal species and also to humans, of course. Yeah, so as you probably know, zoonotic diseases represents more than 60% of all infectious diseases known in humans. Some studies even have reported a higher percentage of these numbers. And here in this graph is just a representation of some of these diseases, virus disease, but also bacterial, or even the bovine spongiform encephalopathies or prions that you can see on the right side. So some of them, they can jump from, for example, livestock to humans, others from wildlife to humans, and some of them, they can interact between wildlife and then jump to livestock and then to humans. So it's a really complex, let's say, situation. We know plenty of this disease that jump from species to species, and this is of course really interesting. So this next slide is quite simple, let's say, but I think it's interesting, how it can be transmitted. There are different routes, and it's really complex. So this is just to summarize that the transmission can be via direct contact. That means that so an animal or a human, it's in direct contact via touching an infected animal, for example, or being bitten for this animal that it's infected. So really in contact, with some of body fluids, for example. The other route is via indirect contact. So we are in contact with some areas where infected animal lives, and then that means, for example, that we can drink contaminated water or touch some objects or soil that are contaminated for these infected animals, or also via consuming food, contaminated animals, for example, also. And then, of course, really, really important, these diseases that are transmitted by vectors. Normally, we think about insects, and the insects can transmit a lot of disease to animals and also to humans, or to first animals and then humans, and the interactions are really, really complex. So I don't want to enter in detail in this slide because the other speakers, they talk a little bit about this ecosystem interface, so the human livestock ecosystem interface. But of course, to understand why a disease can emerge or even re-emerge and persist to a given place, we need to think that human has a lot to, so it's really responsible, let's say. When we think about human environments, where we live, it's really important that the population density is increasing and increasing, but also the mobility. So we're talking also about globalization, no, in the last two talks, but also of course growing poverty, so the how we live, no, and lack of infrastructure also. And then if we move to the natural ecosystems, what is happening, no, in the real nature, let's say, so that we are using this land also, that we are doing non-regulated tourism, so the biodiversity is losing. And I think that this, Fernando explained it really, really good. So I'm not going to enter to this. But of course, if then we move also to the food and agriculture system, so it's really important and affecting a lot to these disease interactions, that trade in live animals and also animal products, the globalization of products. So also mention it, no, maybe should we buy only, or let's say in a closed areas, not going to buy some food thousands kilometers far away of our home. So, but how animal disease can become, let's say, no, human disease. So I think this graph, I'm not sure if you can see the last part, but is really a good summary of how virus can emerge. So first of all, we have the virus here. For example, this is a coronavirus. And then this virus find animal species, for example, and adapts to this animal species. Maybe it can be after some time that it's trying to adapt. So for example, in the case of Ebola virus or SARS or MERS coronavirus, a bat can act as animal reservoir. Then this virus can adapt to another host. So it's changing of a species, it jumps the species barriers. And here the example of SARS coronavirus, the first one in 2002, 2003, the virus adapt to civets. And then after jumping to civets, again, the virus jump another species barrier and jump to human. Here, the virus can try to adapt and then can mutate, and then the transmission to humans, between humans, can be easier or not, depending on the adaptation of this virus, no? And then it can disseminate to the whole population. And then here in red, as you can see, no, I wrote like the severity of infection of this virus. It often, not always, but often it increases with every step, no, from the original species to the final species, let's say. So here is one of the examples. This is the Nipah virus, let's say, transmission cycle. Here, only the important thing, just to point that, for example, on the right side, what you can see is a direct contact with, so the folks, the bats are the reservoir, and then they contaminate some of the foods that then some people were eating directly these contaminated foods, but also it can be, the transmission to humans can be via an intermediate host. So if you go to the left side, let's say, of this slide, we can see that bats were also contaminated some foods or some soil that the pigs were in contact, or horses, and then these animals were in contact, the infected animals, with humans, and in some cases also happened the human-to-human transmission. Another example is the Ebola virus transmission. So what we also know is that the main host is the fruit bat, and then from the fruit bat, the virus, Ebola virus, jumped to another species, mainly non-human primates, but it was also described to other mammals. And then humans get infected via direct contact with the primary host or by the intermediate host. That means via direct contact with blood or other body fluids. And then from human to human, the same, this close contact and then via mucus or also via bodily fluids. So there are viruses that are adapting to jump from one species to another. So what happened with this currently pandemic, the SARS coronavirus 2? So this graph, as you can see, well, we know coronavirus since several decades ago. On the left side, these are human coronaviruses, the ones associated to the, let's say, the common flu. And then they had an animal origin, but it's true that when they jump to human, mainly they are now exclusive human-to-human transmission, and this transmission is quite high. The thing is that they are low pathogenic coronaviruses. On the right side, we have the moderate to high highly pathogenic zoonotic coronaviruses. And then, as you can see, the first one is SARS coronavirus, the one that emerged in 2002, 2003. So we know that the origin is bad. And then we are quite sure that it jumps to civets, as I told before, and then from civets to humans. And then there is like a moderate to high transmission between humans. That's true that in less than 1 year, this virus could be controlled. And then since then, we don't know any other cases. If we go to the right side, we have the MERS coronavirus. We know that probably the origin is also bad. The intermediate host are the dromedary camels mainly, and then with a close contact with dromedary camels, humans can get infected, but that's true that there is human-to-human transmission, but this is low to moderate transmission. What happened with the new SARS coronavirus? We know that probably the origin is bats also. We still are not sure about the intermediate host, but we think that there is an intermediate host. And then this virus jumped also from this intermediate host to humans. And the problem here is that the human-to-human transmission is really high and efficient. So as I told you, we are quite sure that the origin of the SARS is bad because different groups, scientifics, they have found more than 96% of similarity between some bad coronaviruses and this new SARS-CoV-2. Also, there are other studies that evidence that bats are susceptible and can transmit the virus. But as I told you, also several reports, studies, news, they have suggested some different animals as the possible intermediate host. We are nowadays not really sure which one can act as intermediate host. I'm sure you can, you have heard about pangolins or maybe also turtles or the civets and chickens. Some of them, so we know at least now that chickens, they are not susceptible and they are not good transmitters of this virus, but we are still studying several animals. And we can discuss later on, because I'm sure you have also heard about cats or tigers as at least as susceptible animals, let's say. And that's it. Just wanted to show you this picture because, well, this is my group on the middle, but also on the left and right side is how we work with these highly pathogenic viruses such as coronavirus at our institute. And just really brief, we are working as a consortium, and we are working with coronavirus, of course, and importantly, we are working at CRESA with animal models. So we are in parallel, of course, developing animal models to study a vaccine and antivirals. But what we also want to know is, as I mentioned, as veterinarians, we are really interested in knowing this intermediate host. And that's everything from my side. So if you have questions.
Thanks very much for those fascinating presentations. I'd now like to ask rather cross-cutting questions. The first one for you, Julia. The emergence of a new global pandemic had been predicted, as we just heard from the presentations. So why do you think then that the COVID pandemic has taken societies across the globe by surprise? And what do you see, if anything, is really surprising about the emergence of the SARS-CoV-2 virus?
Yeah, in fact, it was predicted since several years ago that new highly pathogenic coronavirus will emerge more or less every 10 years. And that was it, because the first SARS emerged 2002, 2003. Then we have the MERS coronavirus in 2002, and in less than 10 years, this new coronavirus. The thing is that maybe with our previous experience with highly pathogenic coronaviruses, we couldn't expect, at least at the beginning, let's say, of when this emerged in China, that this virus will be really highly efficient in transmitting human to human. This is the major problem, because our experience since 2012, MERS coronavirus only, I will say only, has caused 2,600 cases approximately, and the previous SARS, 8,000 cases. So this rapidly transmission of this virus, so this virus has adapted a lot. So of course we expected, let's say, another new coronavirus, but I think at least at the really beginning, we didn't expect that efficient, let's say, being efficiently transmitted between humans. That's the problem.
Thanks very much. In the interest of time, I'll move on to questions from the audience. And so the first question is for you, David. And the statement was that the causes underlying the pandemic and the societal challenges in responding to it have made it clear that societies need to be more resilient. So the question is, what is the most relevant scale of actions, either local or larger scale, for strengthening resilience? For example, in terms of protecting ecosystems, transforming cities, or decarbonizing our energy production? Yeah,
no, that's a big question. That's a again, I think the answer to the question, what level is most important? The answer is yes. They are all very, very distinct. I mean, in thinking about what we're facing now, from the sort of the global drivers of the epidemic, all the way down to who you were sitting next to on the subway, it doesn't get more global and local than that. I think that in terms of the issue of resilience, it is a matter of how do you prepare for certainly to some degree predictable but very rare events. And I think about the ways, again, if they're useful analogies, the way we prepare for earthquakes. Well, they will happen. We design buildings with a certain plan in mind. We have a contingency plan. And I think that for resilience, it's in part accepting reality that this is probably, this is not the last one like this we will ever face. I think that seems pretty certain. And having a plan ready so that there's not that flurry of panic. At least in the United States, I think it's been bewilderment as the initial response. And ideally, you would have ready both the psychological aspects of, okay, here's what we're facing, and then you would have a contingency plan that evolves based on data. Maybe it's just my own desire for having a methodologic approach to these issues, but I think that that's the only way you can be prepared, is to have a plan in mind and react to the particulars as they unfold.
Thanks very much. So the next question, which has come up through the chat, this was the most highly voted question. Fernando, if you can take this question. And the question is, what do you think of the role of food systems in the day after, considering food systems are the cause for much of the world's biodiversity loss, what should change? Should they become more local? Should governments incentivize change in eating habits, for example, with meat and dairy consumption? And what would be the role of small farms? So Fernando?
Yeah. Yeah, okay. Well, this is a very important question because in many cases, the problem got started by eating or contacting or hunting or poaching or trafficking with new species, no? And this exposure to new species, this habitat destruction or affection, or the fact that human beings were doing more and more activities in new environments and moving new species is really a big deal. The bush meat, the so-called bush meat, is really a source of many zoonoses and many problems. And also it is feeding this vicious cycle, no? The fact that we are empowering, making more poorer ecosystems by removing species. So it's a circle that goes worse and worse and worse. And I think there are international agreements that are enforced to prevent that, but as we see, they are not working at the local level. Some local activities are still going on, and probably it's not a question of banning them or making them completely illegal, but to educating people on using other resources, not exposing themselves, not exposing all of us, and also working with local communities for new opportunities in exploring the resources. Because the banning, the fact that you forbid certain activities is, as we see, is not enough to prevent those activities. And I was checking in the web page the fact that actually this year, the 2020, has been called the super year for biodiversity. Is the year in which many programs, the Convention on Biological Diversity and many global frameworks were supposed to be addressing these issues, like those affecting what we eat, how we relate with biodiversity. And with the pandemics, we are now blocked by the current emergency, and we are not seeing the ultimate causes for those pandemics.
Oh, that's very important issues. So the next question, I'll direct to you, Joseph Maria, because I think it relates to a very key element within planetary health. And the question was, to achieve durable change, should we not be focusing really on ethics and values, since it is essentially the values based on speculation and exploitation of natural resources and other humans, which have contributed to not just the COVID pandemic, but the wider ecological and climate crises?
I think you need to allow my camera. I cannot do directly. The host, well, I can do. Okay, now I am here. Yes, no, thank you for the question. I think it's a key issue to take the question to the framework of planetary health. I think it's very interesting to remind that the founding paper of the planetary health concept, 2015 in Lancet, made a lot of emphasis in 3 types of fundamental challenges. One were the challenges of imagination and conceptual. The other were the challenges of knowledge, and the last one was the challenges of governance. And within the challenges of imagination and concepts, there was the ethics. And the one central question here is the issue of our relationship as human civilization to nature. How do we relate with nature? And this is it's a fundamental issue. I think that it's our divorce with nature. It explains a lot of the difficulties we are dealing with. And it's not only a matter of economic systems and politics, it's also a matter of science, how we as a scientist relate with nature. I remember the very nice explanations of James Lovelock in the Gaia theory, telling the price he paid in terms of credibility when he adopted the Gaia theory, just because he presented the Earth as a living being. And this prompted a tremendous disbelief by scientists. I think this is a fundamental question. We need to make an effort to put the discussion of values and ethics in context. Going back to the question that you make to Fernando about the food systems, and I think that it's good to contrast what Fernando was saying with the other side of the context. So we have one side, we have hunger and extreme undernutrition in poor countries. And these are habitats that are probably closer to where big ecological dysfunctions are happening. But on the other side, we have the epidemic of obesity. And we need to put these things in relationship. I think that probably, to me, one of the more urgent challenges we have in nutrition is to decrease the consumption of red meat in rich countries and to decrease CO2 emissions. And I fully agree that regulating wet markets is very important, but probably we need to put in the context of the poor countries and the local populations. And in these choices, as I think very eloquently Fernando put in the last slide, in the different choices we have, there are fundamental ethical and value choices.
Thanks for that. So I'd like to hear from each of our speakers, their sort of concluding takeaways for the discussion today. So, Julia, maybe we can start with you.
Okay. Yeah, to me, well, here lots of things have been raised up as more research is needed, for example, no, as Dr. Savitz said. Also that we knew a lot about new diseases, but yeah, what's happening. To me, one of the important home to take message is the One Health message, let's say. So as I told you, I'm veterinarian, but it's really important. We cannot work alone. It's really important to work with medical doctors and of course also with ecologists and epidemiologists, because alone we cannot take only the animal alone or the environmental alone. And if we really coordinate this, I think we can really go further and know a lot about one disease.
David?
This is very similar, I think, in some ways, Julia's observations, that we all in sciences, of course, are trained in disciplines, and epidemiology is probably broader than most, but it's just such a sharp reminder that when it comes to the policy and societal decisions, there really is a need for very thoughtful integration across these issues. You know, the reactions to the coronavirus have reduced air pollution. Well, that's expected. What bearing does it have on public transportation in the future? Well, that's urban areas, urban living. And so it gets into the ethical issues, the socioeconomic issues. And really, I think that there is somehow the assumption that if each of us generates the right knowledge base, it'll somehow all come together. And I think we honestly need more specialists who are integrators. It is, I think, a very legitimate avenue to pursue above and beyond all of the separate streams that feed into it, is how do you assemble that into prevention, mitigation, societal planning at the very highest level.
Thank you. Fernando?
Yes, I was thinking that for me, the most illustrative learning, in addition to what Julia and David were saying, is the scales of surprise. I think there are different scales of surprise here. We tend to put all the surprise together. Oh, what a surprise. This is a big pandemic. Oh, no, excuse me. the surprise is not the big pandemics. There are many surprises about the details on how the virus works, how it got there, how can we treat the people with the illness. There are many surprises, unexpected little details, but the big picture, it didn't come as a surprise for scientists. We were telling that this was likely 10 years ago. Julia was illustrating some time scales for the predictions. Obviously, it is a random thing, and we only assume probabilities. It's not an exact mechanism, and we cannot make predictions exactly the day, the 25th of May next year. But we knew enough, and we didn't do anything as a society in general. And I think in part of the problem is that the scientific language, the scientific knowledge is not coming to the politicians or to the levels of the people that are making decisions. And we are kind of illustrating in our scientific journals the details of the pandemics or the other kind of zoonosis and their relationship with environment and the relationship here and the impacts on economy and the impacts on health. But this is not reaching the decisions. And I think there are different levels of surprise, and we should separate. Part of the surprise is not a surprise.
Yeah, that's a very interesting observation. Joseph Maria?
Well, if I had to say to add something to what the previous speaker said, I probably would say that this pandemic to me is interrogating probably in a way that never happened before, the dialogue between the science and the politics. And in this way, I would say that from the scientific point of view, we are faced with a tremendous level of complexity. And David made an emphasis about the integration. I cannot agree more. But I think that we need a fundamental effort to scale up multidisciplinarity. We have been saying that for the decades, and this is urgently needed to a larger scale than before. And from the political point of view, so beyond becoming politicians, that well, there's a good debate in Europe about the virtue of being a scientist for politics in the case of Merkel. But well, putting this aside, I think that the fundamental question for science is how we make science influential. And I think this is, again, it's another interrogation for science. Thank you.
So that leads me to my next question, which is really, where are the main knowledge gaps that we should be highlighting through these discussions? We want to develop a sort of research agenda as well as an action agenda. So what new knowledge do we need? Obviously, in very general terms, there was already good understanding that something like this would happen, although the specific details were not clear. So is it really a sort of knowledge translation or a science to policy knowledge gap that is the most critical here, or is it something related to more either ideological research or something related to the role of human activities in promoting this type of emergence of new viruses? So just Ria, if you could share with us very briefly your thoughts on the key knowledge gaps we should be highlighting.
Well, if you want, I can start with something. And I would say in two different, I will approach the question in two different ways. I mean, one is how we, from my field, from epidemiology and environmental epidemiology, how we can contribute. And I think that we can contribute in many different ways. And Dave has made a very inspiring list of opportunities. But I would highlight two areas in which we can contribute. One is an area that it's, I think, very important for managing the pandemic in the coming weeks and months. That is understanding the geographical variability and the temporal dynamic of the pandemic. And the temporal dynamic, it includes seasonality. And I think that in epidemiology, we have a long track of methods and theories to deal and to understand geographical variability and time patterns. And this is an area where we can, I would assume, make contributions. Just to put an example, I remember the pioneer work of Xavier Rodó showing the contribution of large-scale wind fluxes, probably transporting maybe living organisms from Asia to South Pacific, producing Kawasaki disease. This is a very basic study, but it shows you the scope of our contributions. The other one is the exposome. So our discipline has evolved a lot to the exposome field and trying to understand the interaction of multiple hundreds of factors together. And again, David suggested the importance of microbes in this context. And I think that for the people working in exposome, more attention to infection, it's going to be very, very relevant. From the other perspective, it's how we can learn from other disciplines to fill gaps. And I would say that probably one area is complex systems. I mean, ecologists are minded to think in complex systems. We, as epidemiologists, are more simple-minded, and I think that it's a lot we can learn from ecologists and other scientific disciplines to think in terms of complex systems and approach gaps that perhaps we can contribute to as epidemiologists.
Maybe I continue with just a little reflection. I think there are at least three groups of gaps or gaps in knowledge. The details, the scientific, fascinating, intriguing, important details on the virus, on the biology, on the infection, on the many details. This is a group of important, very specialized, highly specialized gaps that will be eventually be covered and addressed. Then there is another kind of larger type of gaps. And in my area, I think one of those coarse grain gaps refers to restoration ecology. What kind of activities to help nature to recover the function? No? And this is a very complex thing because we know when a function is lost, but now it's hard to know how can we recover it and to which level this function affects, for instance, the probability of pandemics. This is a big, big gap. And the more general gap that I think everyone should perhaps add something to it is how can communicate to normal people, to the humanity, to the population of the world, the close links between our health and the health of the ecosystems. Because if we manage to communicate that, to illustrate with examples, to use the right words, to put in the terms that everyone can understand, then most of these programs, most of these gaps will just be addressed quickly.
Yeah, sorry.
Go ahead, please.
Okay. No, I was about to say that I totally agree with Jose Maria and Fernando, and especially also with this last thing. It looks like, at least with this, at least talking to me, with this pandemic, we learn a lot how to communicate to people, but this is really, really important because we realize that maybe basic questions are the most important one, as for example, what can I do with the animals? How can I protect myself? All these special questions. So maybe we are really focused on research gaps, no? And how this protein is working, how can I find this drug? But maybe also it's really, really important, the society part, let's say. So we were talking about, no, or at least I was talking about veterinarians, doctors, ecologists, but also the sociological part. I think it's really, really important. So we cannot forget about it. And as I told you, at least for us, we have seen clearly with this pandemic that this is one of the most important things, how to reach not only the other scientists, but also the population, no? How to transmit our message.
Yeah, and I was just going to say, it's again a different way of framing it, but this, you mentioned, Catherine, the issue of knowledge translation. And I think that we will never have enough information. We will always wish we had more, but we have to be ready to use what we have as we find it. And I find it very strange that, again, in the US I'm most familiar with, but there are these certain selected areas that are the key problem areas of nursing homes and prisons and urban areas, and we somehow are reluctant to use the little bits we have as we wait for more details to emerge. Young people do better than old people. Well, we can use that, and I think it's a matter of trying to accept that we'll remain a moving target, but we need to move with it.
So thanks so much for this very stimulating discussion, and also thanks for the people behind the scenes who made the technical support, made this event happen. And just to say, this is the beginning. This is session number 1. We have 2 more sessions planned. The next session will be the 4th of May. And here, with this session is entitled The Year After. We will focus on priorities in the near term for protecting health in the face of the enormous societal changes that have occurred directly due to the pandemic, but also indirectly due to our response to it. And the final session, the 11th of May, will be much more focused on developing an action agenda in collaboration with El Dia Después and the activities that they have outside of these expert discussions. And here we will try to create the same sense of urgency that we've seen in the response to the COVID pandemic to address these sort of broader climate and ecological crises and make durable progress towards sustainable development. So with that, I'll close the session, and thank you very much for engaging with us.